Hello students, welcome back to the discussion of the chapter Electrochemistry, and we are going to continue our discussion with respect to sums based on Faraday's laws. Okay, so let us take a question here. It says that in a certain electrolysis experiment, 0.79 grams of silver was deposited in one cell containing aqueous silver nitrate solution, while 0.231 grams of an unknown metal X was deposited in another cell containing aqueous XCl2 solution in series with AgNO3 cell. Calculate the molar mass of X, and you have been given the molar mass of silver as 107.9 grams per mole. Now students, one thing you please understand here, that in this question the cells are connected in series, and that's the reason this numerical is based on Faraday's second law of electrolysis. Alright, so now here let us start our discussion for the solution here. So quickly write the data which has been given as amount of silver produced is 0.79 grams. Amount of metal X is given as 0.231 grams. Molar mass of silver is given as 107.9 grams per mole. Okay. What we are supposed to find here is the molar mass of metal X. To find the molar mass of metal X, the formula which we are going to use here is, first is the mole ratio. And the formula for mole ratio we very well know. It is nothing but moles of substance formed upon number of moles of electrons required for half reaction. And to find the molar mass, we have the formula for number of moles, which is nothing but mass of substance deposited upon molar mass of the substance, isn't it? Through this formula, we will be able to find the molar mass of the substance. So, let us now get into the discussion of the solution of this particular numerical. Okay. Now here, to use the formula for the second law of electrolysis, let us first of all find the moles of silver produced. And for that, we need to have the half cell reactions for the formation of silver and X. Alright. So here, half reaction for silver is Ag plus 1 electron giving you Ag. So here the mole ratio comes out to be 1. Similarly, I need to find the mole ratio for X. Now the problem here is we have not been given the valency of X, but we know the formula of chloride of this particular metal X is XCl2. So can I say that the valency of X is nothing but 2? So now if I want to write the half reaction for formation of X, can I write here as X2 plus 2 electrons giving you X, right? So here now, if you want to find the mole ratio, again, we are getting 1 mole of X here, right? For which we need 2 moles of electrons. So in short, the mole ratio here becomes half, isn't it? So we have found the mole ratios of silver and that of X, right? Now, let us find the number of moles of silver, which is nothing but mass of silver upon molar mass of silver, right? So the mass of silver here is 0.79, molar mass is 107.9. So on dividing, the answer which we get here is 7.32 into 10 raised to minus 3 moles of silver, isn't it? So now what we have found is moles of silver and the mole ratios of silver as well as X. So according to the Faraday's second law of electrolysis, we have the formula here, which is moles of X deposited upon moles of silver deposited, which is equal to mole ratio of X half reaction upon mole ratio of silver half reaction. Okay. So simply we need to find here, through this formula we will be able to find the moles of X deposited. So moles of X deposited upon moles of silver, just now we have found 7.32 into 10 raised to minus 3, which is equal to mole ratio of X half reaction is half, mole ratio of silver is obviously 1. So precisely that is nothing but half, isn't it? So here we are going to continue our discussion for the calculation of moles of X deposited. So can we say moles of X deposited is nothing but 7.32 into 10 raised to minus 3 upon 2, isn't it? So precisely the answer here comes out to be 3.66 into 10 raised to minus 3 moles of X. Now students, we have found here the moles of X which are deposited. And we know the formula for number of moles of X, which is equal to mass of X deposited upon its molar mass, right? So easily we will be able to calculate the molar mass of X by substituting the values, right? So moles of X produced is 3.66 into 10 raised to minus 3, which is equal to mass of X is given as 0.231. So here we'll be able to find the molar mass. Okay, so molar mass of X is 0.231 upon 3.66 into 10 raised to minus 3, which gives me the final answer as 63.11 grams per mole. That is the molar mass of X. So I hope students, you have got a clear idea with respect to this numerical, which was based on second law of electrolysis. Thank you.